Oh man, I could never win these things. The claw is not strong or precise enough to give me the prizes that I want. But NASA has a robotic arm that makes the crane game a cakewalk, and on a much bigger scale. Find out more next on Real World. Without robotics, major accomplishments of building the International Space Station, repairing satellites in space, and exploring other worlds will not be possible. Robotic arms and hands are used on the space shuttle and the space station to build, repair, investigate, and more. The Shuttle Remote Manipulator System, also known as Canadarm, maneuvers payloads from the shuttle bay of the orbiter so the loads can be transferred to the ISS or launched into orbit. The arm also contains instruments to help inspect the exterior of the shuttle for damage. And astronauts can be tethered or anchored to the arm during extravehicular activities or spacewalks. Let's size up this gigantic robotic arm. Canadarm weighs a bit more than 410 kilograms and is 15 meters long. When the arm is on Earth, the motors are unable to lift the arm's own weight. But in space, the robotic hands can lift a massive 29,484 kilograms. That's a whopping 65,000 pounds. But if you think that's some heavy lifting, check out the SRMS's big brother, Canadarm2, the remote manipulator system on board the International Space Station. The even more awesome Canadarm2 can hold up to 116,000 kilograms. That's almost 4 times as much as the shuttle arm. And Canadarm2 is slightly longer, about 17.6 meters long. The ISS is about 109 meters long, so unique engineering design on Canadarm2 allows astronauts to reach just about every point on the space station. But wait, how is that possible? It's made out of aluminum, which isn't very stretchy material. I'll let our on-orbit astronaut, Bill MacArthur, explain.
This is what our arm looks like. It has 2 end effectors, and each of them has 3 joints. They're identical. And then it has 1 joint in the center for a total of 7 joints. And that allows us to do several things that are very, very interesting. One is it means that either one of the ends can be the base. Basically, we anchor the SSRS to one location, and then using it just like an arm, we're able to extend it, move around, grasp objects, lift them up, reposition them, and install them in different locations. Now, because both of the end effectors are identical, the base and the tip, we can actually reverse them, and the tip can become the base, and the base can become the tip. And what that allows us to do is to move the arm to different locations. And so we could have the arm in one location, we could move it to another location, make the base the tip the base, and then we could move it again. And that way we're able to actually position the arm in different work sites around the space station.
Combined with the tracks along the length of the station, strategically placed grapple fixtures put most of the ISS within reach of the long robotic arm. Now, Canadarm2 may be a powerful robotic inchworm, but it's not autonomous. That means it still needs to be controlled by humans. And this controlling is done at one of the workstations. As you can see, the workstation has several monitors and input devices, keyboards and joysticks, hooked up, so they can control the motion of the arm with the joysticks and laptops, and keep an eye on their work with the numerous monitors mounted on the outside of the ISS and Canadarm2 itself. It's kind of like a really big gaming rig if you think about it, or a really big claw machine, maybe even with a little helper on the claw.
Well, gosh, I've talked a lot about sort of in general terms, how we operate this arm, the images we get. Well, what do we actually do with it? Well, it is a robot. So robots are designed to help people do productive work. Every element of the International Space Station, except the Russian elements, were assembled using robotic arms, either on board the shuttle or on board the SSRMS here on the space station itself. We can even put a special foot restraint on the end of the arm, and an astronaut can slip his feet into the foot restraint, and then we move that astronaut wherever the work site might be.
Learning to use these gigantic robotic arms takes a little practice. Astronauts spend many months learning about and practicing to work with robots in space. Instructors on Earth use high-tech simulations and virtual reality environments to teach the astronauts all they will need to know. During her first shuttle mission, STS-131 astronaut Dottie Metcalf Lindenberger operated the shuttle arm to inspect the space shuttle for damage. Other members of the crew used the space station's Canadarm2 to move the equipment from the shuttle to the station. Just think, the science and math you're learning today may help you design an exploration robot of the future. You can learn more about NASA robotics and find out about robotics competitions for students like you at www.nasa.gov. Be sure to check out how Robonaut 2 will be used to help out on the ISS. Right now, I've got a robot to program. Catch you next time on Real World.